Hi, Dr. Janbeck. I just wanted to introduce myself. I'm the one that's been emailing you frequently.
Hi. Nice to meet you.
Nice to meet you. And thank you again for joining us today.
Yeah, I'm happy to be here. So yeah, thanks for your help in getting it all organized. Everybody's been great who's been communicating with me. So I see that we're already live streaming. So hello to anyone who's watching there as well. What is your background, Rhett?
That's the Rachel Carson Reserve. The reserve is in the town's jurisdiction. We have 30 wild horses here. It's a great research area for us, and we're very close to the Cape Lookout National Seashore, where there's 120 wild horses there.
Yeah, I've been there briefly for a NOAA meeting once, and we actually did some marine debris tracking. I think on the edge of the reserve. I did not see any horses there. So my picture is actually North Carolina. It's not near Duke, but or the coast, but it is where I was last weekend in North Carolina doing some beautiful mountain looking.
Fantastic. Stephanie, should we get started?
Yeah, I think that's a great idea.
Okay. Hey, I'm Rhett Newton from Dave Johnston's lab, and I'm joined by Zoe Diana from Dan Richoff's lab. We have the honor of introducing Dr. Jenna Jamback, a professor in the University of Georgia College of Engineering. Jenna is internationally recognized for her research on plastic waste in the ocean and for the Marine Debris Tracker app she co-created with fellow faculty member Kyle Johnson. Jenna got her bachelor's, master's, and PhD in environmental engineering sciences at the University of Florida. I met Jenna for the first time during the 2015 North Carolina Marine Debris Symposium, and that was shortly after she had released her landmark 2015 paper, Plastic Waste Inputs from Land into the Ocean, where she estimated 8 million metric tons of plastics enter the world's oceans every year. Jenna was named a National Geographic Fellow in 2018, and she conducts public environmental diplomacy for the U.S. State Department's International Informational Speakers Program, which has sent her to 14 countries around the world to discuss and collaborate on addressing plastic pollution. Jenna, thank you for joining us today.
Thanks so much for having me. Good afternoon, everyone. I'm going to start by sharing my screen. And it's already set up for slideshow, which is nice. So yeah, it's great to be here with everyone and be able to talk a little bit about science and I think a little storytelling as well with my dual role as a fellow at National Geographic. Just to give us some context and sort of talk about some of the global modeling and papers that we publish, I want to start off with this as, looking globally at plastic as a relatively new material. I mean, that there's many people on here who study it, so I don't, maybe need to go into too much detail, but, if you just reflect momentarily on the fact that really, we weren't using much of this material in 1950 and how it is sort of exponentially increased. We now probably can't imagine our lives without it. One activity I do with some of my students is have them record everything they touch in 24 hours that's plastic, just to realize how it's kind of embedded in our lives and reflect on that. So as of 2017, we had created 8.3 billion metric tons. And, that's sort of an incomprehensible number. And even if we try to put it into a format that we can imagine, 80 million blue whales is hard to imagine as well. So, but the point here, thinking about what we had done with that plastic, because a lot of it, about 40% is used for single use and packaging, that means that 6.3 billion metric tons had become waste already by 2015. And we've had to manage that waste somewhere on our planet. And compiling those numbers, seeing that we've only been able to recycle about 9% of that on average globally. One of the things that we sort of find so useful about plastic is that it can be soft, rigid, film-based, so many different colors, different additives that give it different textures. All of that variety is what makes it really challenging to recycle on the back end. And that really meant that about 79% of it, if it wasn't incinerated, was ending up in our natural environment or our landfills. So talking about sort of where we find really everywhere we look, from the tallest mountaintops to the deepest depths of the ocean, we find plastic. In some cases, we're exploring places where humans have not been yet in the ocean, but we find plastic. And this graphic really sort of illustrates a couple of the things. One is the research that Rhett referred to, our land-based work, where we published the estimate of what was coming into the ocean from the land. And the other is actually samples that have been taken on the surface of the ocean and the concentrations that are seen there. We know that what we find on the ocean surface is probably less than 5% or so in terms of when they model that up to a quantity of what we see going in every year. So we still have a data gap with the question, where is all the plastic going? And we know that there's sinks in terms of deposition, sites, islands that interrupt those large currents in the ocean where plastic ends up. I think, there was a new paper that just came out that even just some of the plastic on the bottom of the ocean is millions and millions of tons. So we know that there are sinks around where plastic is going, and then questions remain about fragmentation and measurement. How small of a particle can we even measure? A lot of this data is just 300 microns and above that's recorded on the surface. The yellow are the riverine inputs. So really sort of when we did the land-based data and then we have the ocean-based data, what is the big connector there? Well, our watersheds and our rivers really act as conduits. So looking at, what's coming out of our rivers, and I'll be touching on that further when we talk about our expedition. Another global project that we looked at, and this really came out of that original 2015 research when we were looking at where plastic was mismanaged, and a lot of folks were bringing up, well, did you know a lot of materials actually exported from the U.S. to other countries for recycling? And we wanted to look at that. So we compiled, Amy Brooks, one of my PhD students, 28 years of UN Comtrade data. And you can really look at the influence of global trade policies, global trade encouraged by the World Trade Organization, and also the the push and the move to single stream recycling, which has really increased the quantity of materials ending up in our recycle bins, but also made it much harder on the back end to separate those out. And so our commodities coming out of our materials recycled facilities, material recovery facilities, is not as clean. So secondary sorts happening. And so before the end of 2017, about 50% of what we were sending for recycling was actually going to China alone. Through this work, while we were doing this work, the policy, basically the import restrictions were coming down from China at the end of 17. And that, of course, has had to drop off. It basically resulted in an import ban, not just of plastic, but of other materials like paper as well. But we saw that most of the exporting was happening from higher income countries to lower income countries. So this has been an important trend to examine and to really look at how countries recycle and are responsible for their materials in the long term. So now I'm going to focus a bit on that riverine aspect. So we were able to do some of this work along the Ganges River, and I'm going to give a little context here and why we're calling this from sea to source. So the Ganges River basin itself, it covers over 1 million square miles. It encompasses parts of India, which is the most, China, Nepal, and Bangladesh. For this work, we were in India and Bangladesh. I would say, this is one of the most beautiful rivers in the world. I grew up on a river myself in Minnesota. Unbelievable diverse terrain, habitat, animals, but it's also under a lot of stress. It's one of the most populated river basins in the world, with about 400 million people directly dependent on the river and its tributaries. It's also a very sacred river. It's a holy river to many, and it's not just known as the Ganges, which we maybe know it as, but in India it's called the Ganga. In Bangladesh it's known as the Padma, and near its mouth the Meghna. And the discharge, so this top picture is the mouth into the sea, 7 miles wide and basically like the ocean. But the discharge is 38,000 cubic meters per second. So you can imagine this bottom picture is getting closer to the source in the mountain. So you can imagine the sites that we saw, the different sites that we saw, the variability along the whole way. So thinking about, this large river and relying on it, it had been used, I think, and seemed to be sort of a vast and never-ending resource. And I think we think about a lot of our resources that way, many of which are stressed already. And, it's also currently used in some places as a solid waste management system, because there's no other ways to have waste taken away. So depending upon the reference, it's either ranked 2nd or 6th in the world for plastic inputs into the ocean. So that yellow data that I had on that other graphic. But this was all completed with modeling of existing data. So our goal in sort of entering this system was to collect empirical data in collaboration with in-country partners, both in India and Bangladesh, as I mentioned, who wanted to know more about the flow, load, and characterization of plastic pollution in this river basin. So we together designed the first sea to source expedition, and we executed this expedition in 2019. So we were there, a little bit more than 4 months' time. So as I mentioned, so this is a little animated map of where we started down here by the sea. Oops, sorry, wrong way. And went to three cities, communities and cities within Bangladesh. The first one was where that picture was from. It was a small community, heavily reliant on fishing. The second community, Chandpur, was a larger city port area. And then we went to a smaller community, but very reliant on the river, called Rajbari. And then this was all by boat. So all by boat within Bangladesh. And then we had to fly over to India. But then we went to 7 communities there, starting in a smaller community called Sahibganj, and headed to the largest city we went to, 2.5 million people, called Patna. Varanasi, one of the holiest, the holiest city probably identified on the Ganga, and then to a smaller town that actually looked a lot like my hometown in Minnesota, Kannauj. It had many cornfields, the first time I ever saw cornfields within India. And then to an area called Rajgat Nara, and then to Rishikesh, which started to get into the Himalayan mountains, and then all the way to the source in a tiny town called Harshal, and then being able to go to Gangotri, where is sort of the holy start of the river itself. And some of the team was actually able to hike all the way to the glacier that is the ultimate source. In India, we traveled by train, car, tuk-tuk, walking, all of sort of the land areas there. So an amazing, I think I want to illustrate this. It was an incredible collaboration, folks from 5 different countries participating. The in-country partners were really leads on the project within their country, and just an amazing, international, I think, collaboration. I want to give you some behind the scenes look. So here's the boat, the MV dinghy that we lived on, a riverboat within Bangladesh. And then in terms of the work that we did, so all in one location was really cool to do. Surface water, sediment, and then air samples. So sort of we called this 4D because we were also doing then land-based work. Fishing, like what fish are available at the fish market, how are people, what livelihoods are relying on fishing, and then in terms of like fishing nets on the side of the river, investigating, what kind of litter, not just from our regular municipal waste, but what kind of fishing gear and debris is there, as well as then just even talking to fishermen about their experiences. In this case, you can see this fishing net is just full of plastic. And he talked about how, obviously this didn't used to be, but now they're putting their fishing nets in and pulling up lots of plastic within that. On the land, which is the team that I led, I'd like to say this whole expedition was co-led by me with the other co-lead is Heather Coldaway of the Zoological Society of London. And she was really overseeing the water and the socioeconomic portion while I was overseeing the land with my environmental engineering background. But on land, we were doing some work that was really born out of our research group since I was working on sort of the global models, and then started traveling with the State Department. And as the State Department brought me to these different countries and, cities and communities and interfacing with governments around the world, we would talk about the problem and the issue. And then, they might say, okay, well, now we're sort of aware, what should we do? What should we do? And I would say, you're the expert of your community, your context, your social norms, your culture. I can't provide that kind of knowledge. You are the expert in that space, but let's look around your community and what do we see? And as I sort of did that, the idea came, couldn't we make this a data collection protocol, as then we could provide this data or collaboratively collect this data, and communities could then be empowered to make decisions, So this concept is called the Circularity Assessment Protocol, and I guess concept, it's a model that we actually then collect data for. So we look at the input of a material into a community, and in this case, we're looking at plastic packaging primarily. We're looking at sort of the use of that material and how people interact with it in the community. We're looking at how product design influences, and this is basically a measurement of circularity, or sort of this assessment. So how product design impacts that use or reuse. Are there reuse systems as opposed to, or alternative product delivery systems as opposed to single use? And then we split up in terms of waste management into both collection and end of cycle. And then finally looking at what ends up on the ground and using that to sort of inform this whole system. And, kind of, I think these three sort of very simple questions as you look at what's on the ground: what is it? How did it get here? And then sort of what can we do about it? Or what do we want to do about it? So we look at this system, and some of the drivers, I think, of what this system is doing are policies, economics, and governance within that community. And then the influencers are folks that we then talk to and interview. And so it's actually a mixed methods, systems-based model. So we, in terms of like looking at the transects, which are where we collect the litter data, we take a population density profile of the community and split that up, and then choose randomized transects to go within certain squares identified based upon population density. And then we collect all of the data on everything that's on the ground, as well as influencing factors. And influencing factors are like stores, restaurants, parks, park benches, schools, and then also look at the waste management system, trash cans, recycle bins, recycle junk shops, various components that all are sort of influencing factors. So here's just sort of an example of how you might look at litter density and some of these influencing factors mapped together. And you can imagine if you've got many of these transects within one community and then transects across different communities, and how you might be able to normalize and compare these amongst each other, which is what we're working on right now within the Ganges River system. I mentioned we also talk to a lot of people. So in terms of input, what actually for sale to the community, what's available to them, what are they purchasing, what are they using, where do these products come from, where are they manufactured, who are the brand owners, what kind of packaging is there, what kind of alternative packaging is available. So all of that's done through sort of this aspect, interfacing with the community and the shop owners. And then looking at, the system, this kind of, this is a kind of waste management, but when plastic, wasn't around, things like this may have been fine, just an open dumping scenario within a community. But you can see now, and we know with plastic not biodegrading and simply fragmenting over time, I mean, there's lots of issues related to this, but there's, in many cases, literally nothing else to be able to do with this material as of now. And so thinking about how you can, change the system, improve infrastructure, and work with the community on what might work best for them. This is the example. I mean, we kind of look like distracted people on our phones because we're using a mobile app that I'll mention later or give more detail on later to collect all of this data. So the debris tracker that you heard Rhett mention at the beginning, but measuring out the transects and collecting all of this data with our collaborators, and really important to have local people with you because they provide so much context sort of beyond what you might do in just logging what something is. And sort of that second question of sort of how did it get here? Why are people, using this? It's quite important, and they provide so much insight. We also, especially within Bangladesh and India, a large fraction, probably 50 to 60% at least, of materials are managed by the informal sector. And these are people that don't work for the government or any other entity. They're independent, and they're simply working based upon the value of the material that either they end up collecting from people's homes, collecting from the dump sites themselves, or on the ground. And really, if we think about solutions to this issue, these folks have a ton of knowledge. They know exactly what is of value and what is not. And so part of this is looking at what materials are being recycled and flowing through the system and why. And, can you reflect on how that can change the system? And when we look at, how products should be designed, I think these are important knowledge holders and stakeholders that really haven't been included in solutions within the past. Something I wanted to bring up now related to, I think, the global pandemic situation that we've been in, especially in India. This has been interesting. People have been starting to source segregate their waste more because they're actually trying to help protect people from exposure during this pandemic. And so that really wasn't happening before. I mean, it was really left to all of the informal community to do that, but that's been sort of a positive change. But certainly people working within this waste system have been essential workers, and of course, sort of really on this front line in terms of having to, work with materials where they could be exposed to the virus and whatnot. So that's been a real challenge in that space during these last few months. So we also had folks in our socioeconomic team that went into villages especially and really looked at sort of the knowledge, attitudes, and perceptions related to plastic and plastic packaging, and the challenges that they had in these really small communities where a lot of waste management systems were, again, not available. We also were able to use some high-tech systems, and I know this work has been done at Duke as well, but we were able to have a partner here, Ellipsis Environmental. This is Ellie McKay. She flew drone on the riverbank. So we had, mobile app and photo quadrat data collection within the community itself, and photo quadrat work on the riverbank, and that's just a quadrat that we would photograph, so another way to collect litter data beyond the mobile app, and also drone work as well, which was really interesting. And then we developed, in collaboration with folks within the UK, a bottle tag, so being able to put GPS sensors within a device that we then put into the river and also kind of near the ocean. So there was both cellular and satellite-based tags that would say, you know, if something falls in, where does it go? Some of the biggest data gaps still within that modeling and work that we had done are related to how much of actually that is littered on land gets into the aquatic system. And then once it gets into like the river, how much actually gets out to the ocean. We're still working on the land bit. We did a drift card. We actually did an experimental drift card study and had very poor levels of reporting with that. But some of those, you know, some of the experiment methods work and some of them did not. But the GPS tag paper I wanted to mention it's actually in publication right now. So it's been accepted, and we actually have 5 papers right now that are either in review or have been accepted related to this expedition. And there's definitely another 3 or more coming. So that's been really exciting to be able to get the science out there as well. So I want to kind of transition over to, you know, the question, I think, of what can we do then, right? So we're collecting this data, you kind of get this, you know, holistic picture of the issue globally and locally. And so this is a framework that I developed for testifying in 2016, but it's really become a way to kind of look at the whole value chain of plastic and kind of start from, okay, if we want 0 input into the ocean, I would say 0 input into any aquatic system, maybe 0 input into the environment is even a better way to say it, because I've been in the middle of the desert and seen plastic pollution and animals being impacted, like camels, cows, certainly within India itself. So anyway, so thinking about sort of the way that there's all these opportunities, all these steps for intervention along this whole value chain is one way to, I think, approach this issue when we're thinking about solutions and when we see sort of what's happening around the world related to it. And I want to kind of highlight that, you know, data collected downstream, so to speak, is really important to inform what we can kind of do upstream. And so granted, I wouldn't necessarily say we want to concentrate our solutions very far downstream. Otherwise, that's like, you know, mopping up your bathroom floor while your bathtub is overflowing. You know, we're trying to work on turning off that tap, but that kind of data from that material is helpful for informing that. So, or how to do that, I should say. So this I wanted to highlight, you know, and this is sort of a inspirational story maybe for students. When I first wanted to work on this issue in 2001, I was told that nobody cared about it. And I mean, seeing that it's only been 19 years, well, 19 years may seem like a long time to some, you know, I think in scientific disciplines, it's not. And it really wasn't even its own scientific discipline 19 years ago. I mean, there was wildlife biologists, marine biologists. I mean, Charles Moore was reporting, you know, seeing plastic floating in the Pacific. And, you know, but as I said, when I, as an engineer, wanted to study it, you know, I was just told that nobody cared and everyone thought this was very strange thing to want to study as an engineer. I was associating what was ending up in our ocean as coming from land or us doing something wrong in this waste management space, at least one component. Anyway, then to, you know, I guess just last month, the fact that the cover of Science journal was on plastic pollution, which is, again, not even a term that existed in 2001. It was marine debris, is, you know, just, it's quite a big change. So I think we should really be optimistic about the continued change that we can have, although I have to feel like the publication, there was 2 in there that really kind of agreed with each other. They were conducted in parallel, but separately. So I think it's quite powerful that they came to the same conclusion, and that everything that we're doing right now is not even enough to bend the curve. We need to be more aggressive, and we need everything. So that whole value chain in terms of thinking about interventions and how we will reduce that quantity. It's not just one of those. locations for an intervention. It's all of them, and it's all of them, you know, in a really meaningful way. So if we don't, you know, if we don't do that, so our paper said that by 2030, the annual input, and now this is to all aquatic systems, not just the ocean as the 2015 paper, so keep that in mind. You know, even doing some of the sort of the minimal things that are happening, that ends up with 20 to 53 million metric tons of plastic still ending up heading into our aquatic systems by 2030. But with all across the value chain and more aggressive interventions that can be reduced. So let's kind of, you know, these are the numbered steps that I had in that framework. So let's sort of think about, you know, and talk about some of the things that I've seen around the world, or that we know about how we can sort of change this. And I think the first one is the fact that we have a large demand for plastic around the world. And I think for us within the US, this is a really important component. We produce the most plastic waste of any country within the world. We have some of the highest per person waste generation rates. And many of us, the reason I put this word luxury in here, many of us, not all of us within the US, but many of us do have the luxury of access to clean water and are able to get something like a reusable water bottle. I know these are, you know, this is one of those very basic things like, can this really make a difference? And let me say why I still bring it up is because taken collectively, they do. So one thing is like, not just you make this choice, but how do you get more people to make this choice? And I think almost more importantly, if these choices are hard, and I think about this, I mean, I'm a really busy parent, and you know, the convenience that we have related to plastics and single-use items are tremendous, right? And so, but if you want to make these changes and they're challenging, why is it challenging? And who do we need to communicate about why it's challenging? And what kind of systems change needs to take place so that these choices are easier? And that's where I think you can actually then make change. And maybe it's policy. You know, maybe you're advocating with a government for policy or initiating things like that, or again, you know, helping to get collective change in this space. So it's not just about individual choice. And then I think we need to think about how, you know, okay, so that's like if you can avoid it and sort of our personal motivation and change. But then can we think about systems, and this might be product designers, you know, engineers and logistics folks. How can we get products and goods to people without creating waste? So can you decouple meeting people's needs and economic growth, which is always coupled with increasing waste generation? Can you decouple those? So things like Loop, which is a company now where you can get products in reusable packaging and send back. And so again, you're not producing any waste, but you're getting the products. Not necessarily robot dishwashers, but mobile dishwashing units. So many restaurants just don't have the space to wash dishes, and so they have to give out. I mean, I think this could be huge. Like if you think about if you just wash dishes, and restaurants or, you know, small to-go places could outsource that. They actually could certainly offer regular dishes if they could be washed. And then RFID, you know, refillable items, you know, all of this under sort of this COVID umbrella as we've, you know, studied the virus more and more. We're aware that, you know, hand washing and reusable items are okay. I mean, certainly thinking about, I know, you know, drinking fountains and things like that, you know, need to be monitored. And so some of this is challenging, but some of it is definitely still doable within the space we're in. There's also another great company called El Gramo, similar to Loop, in that people have reusable containers that they refill. And have been able to partner with major brands, so people are able to get the products that they sort of know and trust, but then, you know, are able to avoid the packaging. And then, of course, you know, your local small, you know, artisans and craft people and just small businesses that make their own soaps and things is absolutely a great way to get products without packaging. And then I think, so if we are making packaging, we need to consider end of life at our design stage. And this is something, working in waste, really just sort of anything that comes our way, we have to manage. And that's been quite a challenge. The waste stream is very dynamic. I think COVID has really illustrated that. We've seen huge changes in the percent of household waste that's generated as people are staying home. That's increased about 16%. Commercial waste is down 25%. The composition of the waste stream changes. So if you just imagine, and within a week, we saw litter related to PPE, how dynamic our society is. Really, that's exactly what our waste stream looks like. So if we can be more thoughtful about what we design, this is an example of what happened related to an extended producer responsibility law that was passed in Norway, and how bottles were limited by color, types of polymer, toxicity levels, so that they could actually do bottle-to-bottle recycling in a reliable way. Because of this policy and these design specifications. And then we've got thinking about alternative materials. So this is my colleague, Dr. Jason Laughlin, who's the director of the New Materials Institute. And, my system looking at circular materials management is within this institute, but he really looks at new materials. Are there materials that act and behave like plastic, that are polymers that won't have sort of this unintended consequence of not biodegrading, especially in our environment. So not that you ever, want these materials managed that way. And I think part of what I'm here for is to say, hey, as you think about these materials, how do they fit into our existing waste management infrastructure? Do they negatively disrupt our recycle system or our compost system? And so thinking about that. So not something like PLA being compostable, those are only industrial compostable polymers. That has sort of created some challenges, but he's really studying PHA, which we do know does biodegrade. It doesn't need to reach the temperatures that PLA does in a home compost system. But I think it's still questionable about how long something like that would take to biodegrade in the ocean. Again, not where you want these materials to end up anyway, however. So that's another component. And so as we sort of move down that framework, thinking about our infrastructure, so I mentioned, if people don't have any place to put waste, what do they do with it? And historically, what has been done? And so I think a lot of this, we can sort of generally say we want materials collected and then, captured through a management system and then contained either long-term, either recycled into something else or even in a landfill system. But I call this the 5 C's, and not everyone's used to the R's, but context and culture are so important in this space. So we sort of generally all want to do the same thing, but our waste streams are different, and just, yes, our whole the context and culture around waste within places is incredibly important, I think, to take into account, so that it's not really kind of this one size fits all approach related to waste management, but certainly lessons learned, especially as we do the CAP, which is what we call the Circularity Assessment Protocol in different places. Those lessons learned can be shared amongst communities and places. So finally, sort of our last chance. So right before the plastic gets into, well, here in this case, it gets into the ocean, but are there ways to capture it even before that? But this is just an engineering system. And again, collecting data at this stage, and also having somewhere to manage this material. Capturing it here and then not having anywhere to manage it upstream is a challenge as well. But this is our beloved Mr. Trash Wheel in the Baltimore Harbor, where there's now 2 other wheels as well. So, our last chance for capturing this material before it gets to the ocean is important. And we've been doing this many, many years. It's now been 35 years that the International Coastal Cleanup has been conducted by the Ocean Conservancy. And I think recently we've now figured out how important this data is. And I think this past year, I think food wrappers surpassed cigarette butts, which they've been #1 for so long, and for the first time, the top 10 items, became plastic. These are snapshots of a one-day cleanup, but I think quite important to see, again, sort of the trends of what is actually leaking out onto the ground and why, and then what should be done. So here's my little plug for the mobile app, Marine Debris Tracker, but we sort of stress the debris tracker part because, we're using it for CAP within, like all the cities are not marine within India, of course, but along the river and actually any community. So we now use this as our research-based tool, and there's many different lists that can be used. It's easy and I think enjoyable to use for citizen scientists in some of the very simple lists. And then we have our own research list and partnership now with National Geographic for education. And thank goodness, sponsorship now by Morgan Stanley for long-term sustainability. I think we're at like 2.8 million items logged now, and a brand new website, which is really helpful, I think, there's really short videos that we were able to produce related to sort of overall what Debris Tracker is, and then tutorials. So really easy ways to sort of enter into this space. Now we're in collaboration with SciStarter, easy ways to log in through social media, share data, get your own data downloaded from the website, see others' data. It's open data, which we think is absolutely important sort of for democratizing data and allowing, everybody access to it. So this is what the map on the new website looks like. And this is just some of the data that we collected throughout the expedition. And you can kind of see how it goes along. But we also had National Geographic partners, and their media arm was having folks all throughout India collecting data with the tracker as well. And we would hold workshops and education, outreach and education components in school. And that was really, I think, some of the most rewarding work, thinking about the next generation and, them being able to, become aware and learn about this issue and decide what they want to do in their community, become empowered by data, and sort of leaving all of this tool and sort of system with them to be able to work now sort of locally. So I just want to, welcome others, I think, to this space and just talk about the incredible, global work and local collaborations that I think are just really important in working towards this issue, and even the intersections, I think, with so many different disciplines really have continued to come to light as we work more and more on this issue. So thanks to everyone who's already working on this issue all around the world. And thank you all for listening. And I'm happy to take questions.
Jenna, thank you so much for that great overview of your work. I'm always amazed at your ability to go from really large scale down to small scale. So thank you for that.
Sure.
Let's see if there are any questions out there.
Yeah. And I'm happy to take just random, like, what is it like to travel with 18 scientists on a bus or a boat, or
Jenna,
or anything about.
I'll start
Sure.
off if that's okay. So where are some of the countries that have the political will to make a difference? What are some of the templates that you've seen that may be useful for us?
You mean for like us in the US, or?
Yes.
Okay. So I think I've testified now to Congress 3 times, and I think, one thing that comes to light in each of those are sort of this extended producer responsibility policy that I've seen successfully implemented in other countries, and that's provided like the framework, as I mentioned, in Norway for those design specifications. It also, 5 different companies were basically sort of born from that policy because companies needed to start to help the brands to be able to prove, well, they have to show a certificate of recycling, to the government. And so there was actually, economic growth, you would say, because of this policy. So there was, new companies formed. So, but I think the political will within the U.S. is probably not going to go that route. I don't know. I could be surprised. I think we've also seen data, and there's been at least one paper published showing that like deposit return schemes. So when something has value, whether the value is inherent or the value is placed on that item through a deposit return scheme, they don't end up on the ground, or at least less of them end up on the ground, right? So Chris Wilcox and CSIRO showed that in a paper, and that was looking at U.S. data. So I think, and those are implemented in other places. And within India, for example, PET bottles, which is where a common deposit return scheme is placed, it's not actually in India, but those bottles have a large inherent value. So out of, over 70,000 litter items, very, very few PET bottles were found, right? And it was only where that recycling infrastructure didn't exist is where we kind of found those, or if they had already traveled to a waterway. And in fact, those bottle tags, they were, the GPS tags were disguised as bottles. Well, they were valuable, right? So actually that wasn't a very good disguise. In fact, they had to work on disguising them more than that because bottles were picked up. So we had one of the tags picked up and they took the SIM card and used it in their phone. But because the bottle has inherent value itself. So that's sort of, those are things that I think I've seen. And I would say regionally, there's been a lot of good work under like the APEC umbrella, the Asia Pacific Economic Cooperation, ASEAN and PEMC for those countries, I think, that are in a similar region or have similar situations to come together and address this. So I'll stop talking because now there's more questions.
Thank you. Other questions from the audience?
We have Daniel.
I've got one.
Oh, sorry.
The famous Dan Richoff.
Simple question. What is the buzz on the street when it comes to the chemicals that are leaching out of plastics everywhere on land, water, everything? Does Congress even think about that? They've had, that's not my expertise in terms of study, but certainly have, that's something I thought of initially, like when I started this work at the University of New Hampshire, we took cigarette butts because I was like, they found 46,000 cigarette butts once on Hampton Beach. And I'm like, how could that not be impacting, the beach sand, like right there, like kids are playing in the sand. And anyway, and I think now that has been proven. I at the time actually had an interesting high school student working with me, and we did some experiments, but nothing we could publish. But now that has been published that, that cigarette butts leach toxic materials, and there's high toxicity related to that. But Chelsea Rockman has testified to the House of Representatives, and this is more in her space in terms of some of this toxicity. I think what people were focusing on first, the fact that plastic sorbs persistent organic pollutants, right? And so they were like, wow, they're really concentrating PCBs, and there's pellet watch. But then it became sort of this question is like the exposure to an animal, if there's PCBs in the water, they're getting exposed to them by swimming around in that water. How much does the plastic contribute or not? And then actually, if you think about the partition coefficients, if the loading in the animal is higher than what's in the plastic might actually sort of, I don't know if it cleans it out, but you wouldn't have the same kind of exposure, transfer of chemicals to the animals. So then the focus did, I think, switch to what chemicals are the plastics then bringing in and contributing to this itself. So like the BPAs,
all of the additives that I mentioned that make plastic do many of the different things that it does. And that's where the work has been focusing. I haven't really seen a significant, what I shouldn't say not significant, but I haven't seen a global paper yet that says this many chemicals may be coming from the plastic that's in our environment yet. And I think until we sort of have something like that, it's been, smaller studies that have sort of looked at that. But it is on a lot of scientists' radar. I don't know how much it is on the politicians' radar. I think one of the most important health and toxicity components at this time is how much microplastic we're being exposed to in our daily lives and the questions related to that. Thank you for the question.
Thank you.
Thanks for the answer.
Thank you. Joanna, did you have a question? You're still on mute, Joanna.
There we go. Sorry. It was about her take on microplastics and how she, like, kind of what you saw out there and how much it's fragmenting, and like just kind of your take on it.
Sure. So I can't really, I can't sort of comment in too much detail on the Ganges work quite yet, but the microplastics paper is one of those that's in review right now. So that's pretty exciting. But let me talk also about in 2014, I crossed the ocean in a sailboat with 14 or 13 other women. So 14 of us. And we trawled at the ocean surface and saw microplastic there. But I think what was the most, and that was very, I work really only on land. So that was not only eye-opening in terms of, trawling and seeing microplastic, but also just sailing across the ocean for 19 days. But I have to say, what was really significant is before we left, we were in the Canary Islands. So we sailed from the Canary Islands off sort of the north coast of Africa. And I walked up to the ocean thinking, okay, I'm going to be crossing you. And I looked down and like every wave was a confetti full of plastic. And that's where I really had this epiphany moment, this material is getting into our oceans, which I knew, from land, but then it's being churned up and basically spit back out at us. I mean, and again, these are sites that, the Canary Islands are off enough that they're sort of in the southeast portion of that North Atlantic gyre. So they're a deposition site, similar like Midway Island in Hawaii, is within, the currents where, plastic washes up on shore. So it's it goes out, it gets fragmented, and then, in some cases it's spit back out on these sites. And it fragments so quickly. So seeing what we do on land, seeing it within our aquatic systems, it's just, it's very sobering, unfortunately it's not unfortunately, but it's just, it's a hard part, I think, of this project. And it makes me want to figure out how to turn off that tap, because it's so much more challenging to capture it in the stage where it's fragmented, where it's already gotten into the environment or in an aquatic system. And so for me, it's a huge motivator to change the system more upstream. But this is also coming from me that I don't, my focus is not to study that microplastic. And I do think that our exposure to micro and even nanoscale level plastic is where the human health questions are right now. And that probably has the more of a capacity to change things. If we find out that there's human health impacts from exposure to that kind of system, I think that will provide more motivation to change the system probably than anything I would do related to waste. So if that makes sense, it's almost the key But it's the huge motivation for me doing what I'm doing upstream. So those of you studying microplastic, thank you.
Thank you. Nicholas, I think you had a question.
Yeah, I guess it's related to this one. There's two parts to my question. The first is you mentioned the imbalance between the input to the ocean and what is measured in the ocean. What's your feel for, what explains the large discrepancy? Is it bottom sediments or is it the nanoplastics that you mentioned? And then the second part goes to your part about human health. I saw a couple of papers that describe potential nanoplastic or very small plastic going up the food chain. I don't know if that was these experiments were conducted at unrealistic concentrations of plastics, but they fed to algae. It goes into the brain of these small fish, and we've seen it in oysters, for example. Obviously, oysters have plastic, and we eat oysters. So, is there any evidence that there is food chain that it goes up the food chain?
Okay, yeah, great question. So my intuition about where it's going. My first thoughts were that, and this is like the experiment that I tried to design when we were crossing the ocean, was that they were just getting too small to be read, that we just were not reading a low enough size fraction. And I still think that's one of the big reasons that we haven't seen the concentrations that are probably there, I guess, is one way to put it. But at the same time, when particles get so small, colonization by bacteria, their density and buoyancy changes so much. And so I also think then sort of, what some of those natural cycles within the ocean, like marine snow and, things that deposit, that probably a large fraction is ending up on the ocean floor. But I think it's just really, again, a combination of all these things. A lot of it's being consumed, by marine life. And then, you have large masses of it being spit back out onto these deposition sites. And I think one of the biggest data gaps we have is really, where all of this is going. So all I'm giving you are sort of guesses, but papers keep coming out. I wish I could remember. I can't remember. There was a paper in the last 2 weeks that gave a new quantification that was ending up on the seafloor. It was out of Australia. And I feel bad that I don't, but it was definitely millions in terms of the order of magnitude of mass of plastic on the seafloor. And, that already is a big finding that we hadn't quantified before. And that I think is probably, again, a conservative estimate. So your question to the food chain, and I think really to me, I think just what are nanoscale plastics doing? So unfortunately, there was a paper that came out that got sort of mismessaged, saying that I think something like we were being exposed to nanoscale plastic, but all it was an experiment to test to see if it could, cross some of those tissue barriers, which yes, it did. And so that was a very experimental study. And kind of like you're mentioning some of the others, like, that's been fed and they've been exposed under these controlled laboratory conditions. What does that really mean for us in reality on what's happening to us every day? I think in terms of exposure, what we eat, yes, there would be some, but I think, the air stuff is quite interesting in terms of how much we're exposed that way, and probably food from, atmospheric deposition within our own, like if you leave a cup of water, like open to the air, you're going to have particles that settle into that. And so just even the air work has become very interesting. The most recent, I think, just in the past, 2 days, there was a paper that came out that was, that studied warming up water and then adding formula to a baby bottle and the amount of microplastic that was created from that. And it was definitely the fact that the liquid and the plastic were warmed, and then the vigorous shaking that you do to combine the water and the formula within that system that released a lot of particles. So I think just even the science around understanding that, because they were like, well, you could mix the formula somewhere else, like not in plastic, and then add it to the bottle and greatly, greatly reduce that. So just that kind of knowledge is, is so important, to be understanding the formation of the microplastics and how we might be exposed.
Well,
I think we
Jenna,
have something in chat.
let's see. We are at the end of our hour session here. Jenna has been kind enough to say she'll stick around for 15 minutes if people would like to meet and ask her questions during those 15 minutes. Jenna, thank you so much for carving out time for us. This is amazing. Your work. I like the fact that you remain an optimist in a fairly difficult environment. So
Yeah.
Thank you for joining us today.
Sure. Yeah. Thanks to everybody. And I can, like I said, I can stay, and so I could answer Michelle's question. But yes, I understand other people have other obligations because we're at the end of the regular time. So thanks to everyone who was able to join. And wish we could have done this in person, but really glad we could do it this way anyway.
Absolutely.
I'll answer for Michelle. So do you know of any studies in the U.S. that are tracking waste from inland communities into the ocean or estuaries? I'm working on that. So I guess I don't know. I know there actually has been work within Louisiana and Texas, and some estuary related work, and even a little bit of microplastic work on the Mississippi. I do know that actually Rachel Miller of the Rosalia Project had a National Geographic grant and had been doing this work anyway. She has a boat that she sails up and down the Hudson River and has collected a lot of microplastic, and I think also air. I'm not sure about sediment as well. So those kind of studies have been done, but I certainly am very excited to try to complement those studies with our CAP work. And so we're hoping to do some of that. And we have 2 U.S. Cities that we're working in right now. And one of them is public, Miami. So we'll be doing CAP in Miami, which I think will be quite interesting as well. I'll close that. Anything else?
Yeah, I have a quick question. Thank you so much for this super interesting talk. That was really great. I was curious about this recent call from NGOs and businesses for a UN global treaty on plastic pollution. I was wondering what you would kind of prioritize. You've gone from global to local and having this giant treaty. What would you put into it, I guess?
Yeah, that's a great question, and there's been a lot of talk of that. And I didn't get to see. I saw Chelsea Rockman retweeted or tweeted something about companies, actually some companies now supporting this. And I apologize, I did not have time to read that article, so this is me seeing a headline only. But certainly that was, and she seemed very pleasantly surprised, her sentiment surrounding that article. So of course that would be great to have companies supporting that as well. That hasn't been the case previously, but it has been discussed at several UNEAs. And I think for me, and this is even when we talk about the trade, so when we wrote that, and I'm going to use one example to sort of segue into your question. So when we wrote that import-export paper, and we're thinking about, it really seems like a lot of high-income countries were, putting this material in lower-income countries, but yet they want the material in terms of China was a manufacturing hub, so it was using a lot of the material, but others, it is a source of economic, it is a part of their economy, I guess I should say. So, kind of trying to think about that. And, there's amendments now to the Basel Convention, which I think were important, and we recommended that should happen, where, it has to be tracked and identified and notified, right? So, I think you really need to make sure that a country would legally want this material. Of course, there's also illegal trade that happens. And a lot of them don't, right? A lot of them were saying, we don't want this material, we want to send it back. But then you think all about island nations that may need to somehow export, so I think we have to just be careful with some blanket policies, but that doesn't mean we shouldn't do a policy. Some people say, oh, we can't do all one policy, so we shouldn't. I do think these policies, but I think you can be creative and flexible and, allow for people, probably similar to the Paris Climate Accord, right? They spent a long time on that, where it's flexible to where a country's at and what they need in your economic development. I just kind of think about how different the contexts are. In India, it's like 200 to 300 grams, not even 1 kilogram of waste is produced per person per day. And 1 kilogram is 2.2 pounds. We're producing 6 and 7 times that, we're just in a very different context. And so I think their actions may be quite different on what needs to happen than ours, but ultimately kind of the same goal. So sort of as I looked at the waste, like collect, capture, and contain, those are super general, but it's like however works for you, you could do that. So I think having policies in place where we are sort of respecting people's context and allowing them to work within what makes sense to them, but we all make progress in bending this curve, in better, delivery of products, not producing waste, managing the waste that we do produce, that kind of thing. So we just need really thoughtful, creative policies, but absolutely, I think we should have an agreement.
Thank you.
Yep.
All right. Anything else for Jenna? Wow. Well, Jenna, thank you so much.
Wait, Becca raised your hand.
A last minute addition. Thanks,
No
Jenna.
problem.
I actually, it was great to hear more about the Sea to Source project, or Source to Sea, since Taylor Madeline is a good friend of mine. But
oh, good.
I was curious, in working with partners on the ground, I appreciated your encouraging them to be making the decisions because they know what's going to work locally. But how are you communicating kind of your findings and data in such a way that they could use it to make decisions?
Yep. That's a great question. And that is something that has been hampered by, we had plans to go back and plans to communicate, more with our partner, meet with our partners, more communicate with the government. And for example, we had Tata Trust who wanted to help get information out to folks from the expedition. We're still trying to figure out how to do that a bit more virtually. We brought in a couple partners. One is the Wildlife the Wildlife Institute of India, WII, and then IIT, the Institute of Technology in Engineering in India. And so those partners are continuing this work. So like Dubey, the professor at IIT, he's actually somebody I met in grad school. He's continued to do seminars and teaching and, really set him up. This helped to set him up to be sort of someone who could work within the country. WII, actually, the reason we went to some of the cities that we did, and the villages especially, they already have an entire network of people that work within their communities called the Ganga Prahari, which are protectors of the river, and they have gotten funding to expand that work this was just along in the near main stem of the river, and they've gotten funding to expand it to the entire basin, including tributaries. And so we're really kind of relying on them to be able to take this information and continue to work with the communities. Now, these projects don't have they're not just about plastic, they're about biodiversity, protecting the river for many reasons, but we're hoping that they can incorporate our findings and some of the participants have been writing grants to then look at solutions. So as I mentioned, I think the project related to the nets, the fishing nets was, the finding, I guess, related to that was interesting, and people are exploring, some of the programs like networks where, nets can be collected and recycled, and also create community livelihoods for fishermen outside of fishing. That's a similar project that happens in the Philippines. So that's sort of how it's going. But I agree, this is a critical component and not easy, because the way this was sort of constructed, we have to kind of rely on these in-country partners, and we didn't quite have the same community connection that wasn't through them. So we sort of can't directly do that. Like my other CAP work, we have sort of a direct correlation or direct collaboration with the city itself. So that's kind of one difference for here. But our partners, I think, are doing a lot with that.
Jenna, one last question for you. In a post COVID-19 world, where's your next research interest?
Well, so I think, so so you asked about my travel. So I haven't been traveling, but what we have been doing, which I'm finding is really sort of amazing with the CAP is we work in collaboration with an entity, often either a university or an NGO within the city itself, if we were to go do the field work. But guess what? Now we can't travel. So we're training folks to do the field work themselves. And because we use things like Debris Tracker, we see the data being collected in real time. And they use that even for more than litter data. We have lists within there. And, I think it's just been really sort of, I think, rewarding from the aspect of, people are being empowered to both collect the data and then work with us on analysis. And it was something it was a model that we wanted to get to eventually, but COVID just meant we had to leap there much sooner. And I've been really pleased. It's also is building capacity, and we're learning. We get to learn from each other. And that's what I think is so amazing about working with folks all over. It's definitely not a one-way street at all. We get to learn from each other for this kind of work. So, I think that and a couple of other things sort of up my sleeve. Definitely the question related to the U.S. I'd love to look at. I mean, and there's not like a ton of different big rivers in the U.S., but trying to, because I think I've had to actually, and I think it's not. And this is something I brought up even when we were doing this. Well, I mean, so actually, I'd love to do the Mississippi River, so I can definitely say that. But and there's some strong possibilities that could happen. But I think what we need to do is look at our own backyard. So this is not just about us. I mean, I'm just trying to do what I can in terms of my work to help everywhere. But I think it's really quite important to be looking at what we're doing here. And this is an opportunity to do that because we can travel, especially by car domestically.
Well, we certainly enjoy your work, Jenna, and really respect all that you're doing.
I have one more question about India.
Yes, sir.
Oh, yeah.
Last time I was in Chennai, they were going to hire Singapore to deal with Chennai's waste problems. Have you seen that anywhere else in India?
Well, I've seen that in other countries as well. But yes, I'm trying to think of where else in India. But Chennai was one of the places that I went with the State Department, and they're actually doing some, some progressive things there. Both Chennai and Kolkata were great cities. But I don't remember if I saw a facility where Singapore was building, but I've seen Japan in a lot of Southeast Asia, the Japanese development agencies, the GIZ has been doing a lot of work in Indonesia. But, incineration works quite well for Japan. but culturally it is rejected in a lot of places for various reasons that I think are justified. And so that's definitely been a battle. And incinerators have been built in India and then not utilized. And so, yeah, I think that's just one of the realms where I've seen that. But Singapore is another place where, you know, they have technology that they think can be sort of directly exported. But in my opinion, again, if you don't take, you know, context and culture into account, something like that is just going to completely fail. And India is very driven. There's an example I share with my students in my urban systems course about Dharavi, which is what they call slum, one of the slums outside Mumbai. Informal settlement is a better term, I think. But, you know, a guy came to the US, got from India, you know, got educated, had an idea, you know, I want to build these high-rise apartment buildings in Dharavi. Everyone's going to be able to live in an apartment, have their own bathroom, etc. And they completely rejected it. And, you know, it's because they were like, this is, you know, waiting for, you know, the bathroom in the morning, you know, the community, they would just feel so separate. They didn't want at all, you know, so just that whole context of like, you think everyone wants their own apartment and their own bathroom, but no, they don't. I mean, you have to think of a different way to improve sanitation that fits with what they want for their community. So.
Cool.
Yeah.
All right. Jenna, thank
right.
you so much for your time. Really appreciate it. And we look forward to getting our next update from you with your great adventures. So again, thank you for your time today.
Yeah. Thanks, everybody. Have a good rest of the day.
Thank you.
Bye, everyone.